Hello everybody and welcome to another class. This is fractions and decimal equivalents. So there's actually no work that needs to be done on this particular page here. I'm going to open up something here so you can see my cursor a little better. Launchpad. Okay. See that blue dot there? That's where my cursor is. So there's no actual work that needs to be done on this page here, but this is just for reference. But I am going to cover this in our actual work page, so I just bring this up as a reference. Also, one thing that is very important is the decimal and fraction equivalent chart here. This is pretty important. It's kind of like the multiplication table for multiplication, even division and stuff. Use multiplication. So it just makes your work go a lot quicker, as well as if you know this, if you memorize this table here. So for example, 0.1 in decimal is equivalent to 1/10 in fractions, okay? And 0.2 is equivalent to 1/5 in fractions, etc., etc. So knowing this will help you tremendously to go a lot faster. Okay, now that that's said and done, I will go to the next page. Let's see. Okay, so this is our actual work page here. So here we have it. And if you need to, you should probably read over that first page, just kind of get somewhat of an understanding of what we're going to do here. Okay, so here we have our first problem. Let me zoom in a little bit. Okay, remember, read these instructions well and understand them, because a lot of times they'll tell you to do a few different things, like resolve the problem, then reduce it, and then etc., etc., which could give you a negative score on the GED test if you don't do it correctly, or if you don't do it thoroughly, all the steps. So during a 25% off sale, this is number one. During a 25% off sale, store clerks find the amount of discounts by multiplying the regular price by 0.25. What is the discount on an item with a regular price of 80? Okay, so we know that the regular price is 80. Okay, so we are going to do this. 80, sorry. So we need to turn 80 into a fraction, okay? So anytime you need to turn a whole number into a fraction, again, put a 1 under it. That retains its initial value of 80, okay? Anytime there's a 1 under a number, this is the actual whole number. Times the other number, which was 0.25. Okay, this also needs to have a fraction under it, okay? So anytime you see a decimal number, basically you need to have 3 numbers under it, okay? 25% is 25% of 100, okay? If this was 250, for example, then we would need to have a 4th zero. If this was 25000, sorry, 2500, then we'd have to have another. So there always needs to be one more 0 down here than up here, okay? So here we have it. Now what we need to do is cancel out, because canceling out makes the job a lot quicker. So is there any number that can go into both of these? Yes, 1 can, but we're asking anything other than 1. Um, so no for that. Now, is there any number that can go into both of these? Usually you'll pick the highest number that can. That will reduce it the most, well, to the lowest terms. Otherwise, if you pick like a middle number, then it'll reduce it a little bit, but then you can still be reduced some more, and just makes the process more lengthy. But sometimes you have to do that anyways if you're just unsure. Okay, so 20 goes into 100 and into 80. So 20 goes into 100 5 times, so we'll put the 5 here. 20 goes into 80 4 times, so we'll put the 4 here. Now we'll get a much smaller number, which will be easier to deal with. So 4 times 25 is 100. Okay. 5 times 1 is 5. So can this be made lower or reduced? Yes, it can, because 5 goes into both of these numbers here. 5 goes into 100 20 times. So there we have it. 20 is your answer. So if you want to put that in a fraction, it would be 20 over 1. But we're not looking for a fraction. Okay, if this was another number here, not a 5, then you would likely need a fraction. So 20 is your answer. Let's see. Is it an option? Yes. So B is your answer. Okay, so what is the discount on an item with a regular price of $80? So 25% off of 80 is 20. Very nice. Okay, let's move on to the next one. So number 2. I'm going to leave that off. Number 2 is at Linton Products, 3/10 of the workers are in the company's rideshare program. If there are 480 workers, which of the following expressions could be used to find the number in the rideshare program? Okay. So we know we have 480 on all of these. So basically, let's look at it this way. You know, this is the total amount of workers, 480, and this is like a representation in fractions. So 3 is representation of workers that are in the company's rideshare program out of 10, okay? So we know that if it's out of 10, then 10 is the total amount of workers, which is equal to 480. Okay, so that's just one way to think about it. So you're looking for this portion out of 480, which is 10. Okay, and we know it's multiplication because it says of here. Which of the following expressions could be used to find the number in the rideshare program? So we know that it's this number right here. Okay, we know that 0.3. If you look at the equivalent decimal fraction chart that I showed you before on the first page, this would help to know that 0.3 is equal to 3/10 in fraction form. So yeah, that's pretty much how you would do it. Trying to think if there's any other way that I can describe this to be even more clear, but I really don't think there is. Let's see. Okay, so now let's just move on. Okay guys, so we have number 3 here. Sharon is using a calculator to find out how many hours she has spent on a certain job. She divides and her display reads 4.66666. So this 6 would keep on going on to pretty much infinity. So let's look at our chart here, because knowing what 666 actually means, and we all know that's, some people may think of that as an evil number. That's not what I'm talking about. So as you can see here, 6 is this line. Just trying to get a better. Okay, the line right above the 6 there indicates that this will keep on going out. So they just cut it off at the third one and put the line to let you know that it keeps going. So this decimal is equivalent to 2/3 in fraction form, okay? So remember that. This number here is always equivalent to 2/3, okay? Same here, you can see the line over the 3. It means this 3 would keep on going, but in this case it's equivalent to 1/3. It will always be equivalent to 1/3, okay? So let me close this thing here. So just by looking at this, we know that since she divides her display reads 4.6, okay, in fractions, that would be equal to, since we know the 6's are 2/3, be equivalent to 4 and 2/3. Okay, that's why that table is important to memorize. So that is number B, letter B, sorry, that's your answer. Okay, a gourmet candy company, this is number 4, a gourmet candy company changes the following prices per pound. Okay, sorry, I said changes, I meant charges. How much would a customer pay for 1.5 pounds of peanut brittle? So we know that peanut brittle is $12 per pound. Okay, so if they want 1.5 pounds of peanut brittle, that's kind of easy to do in your head because it's a small number. But let's see, we have 12 over here, and we need to times it. Okay, we need to change this to fractions, so I'll put the 1 under it to keep that whole number value. And we know that we need a fraction over here. 1.5 isn't really a fraction, and we can't just put 1 under it. So what we would do is, we know that 1.5 is 1.5, okay? And if you don't know that, 0.5 is always a half. So for example, 0.5, see how it says, see 0.5 right here is a half. Okay, again, know your chart. So we will know that 1.5, there is 1 and a half. So let's multiply that. First of all, we need to change this to an improper fraction. So 2 times 1 is 2, plus 1 is 3. So we'll cross these out. Okay. So now we can multiply it. 12 times 3 is 36. And 2 times 1 is 2. So 2 goes into 36 how many times? Well, half of 36 is 18. So 2 goes into 36 18 times. Okay? So that would be your answer there. The cost of 1.5 or 1.5 pounds of peanut brittle would be $18. As we can see, $18 is an option. Okay? So another way to think of this, 2 divided into 36. 2 goes into 36. Okay, and resolve that problem, you'll get 18. Okay, so number 5, staying live. At 1 p.m., the amount of rain the amount of rain in a rain gauge is 1.0 125 inches. At 3 p.m., the gauge holds 1.875 inches. What fraction of an inch of rain fell between 1 p.m. and 3 p.m.? Well, to find, basically we need to find the difference between these numbers. See how much fell between this time and this time. So for that, we always subtract. Okay, so let's set up the problem here. So we have 1.875 minus, so you subtract the bigger number from the smaller number from the bigger number, like so. Doesn't matter which one came first. So 5 minus 5 is 0. 7 minus 2 is 5. 8 minus 1 is 7. We know we need the decimal point here. And 1 minus 1 is 0. We don't really need to put 0 here, but we will anyways. So, let me see here. What we need to do is determine, what do you call it, which number can go into, well, let's take this 750, which is our answer here, and resolve it into a fraction, into a, yeah, it's a decimal. We need to resolve it to a fraction. So 1,000, okay, because there always needs to be one more digit down here. So what's the number that goes into both of these? The highest number, well, we know, since these are quarters pretty much, since it's, 250, 500, 750, we know that 250 goes into 750 3 times. Okay. We also know that 250 goes into 1,000 4 times. Okay, so we always want to pick the largest number that goes into both of these. And sometimes it will be one of the numbers themselves. Like if this was 250, then we'd know that 250 goes into itself once. We'd put a 1 here, and 250 goes into 1,000 4 times, so we'd put a 4. It would be 1 over 4. But in this case, your answer is 3/4. Okay, so 3/4 right over yonder. That's how much rain fell in between 1 p.m. and 3 p.m. or at least the difference in amount of rain. Okay, last one. A steel rod 3 meters in length is cut into 8 equal pieces. What is the length in meters of each piece? Okay, so there's 2 ways to do this. If you know your equivalency, you put 3/8 and you would know what that equals if you know your chart. Okay, so again, another reason to know your chart, because that would be resolved immediately. In another case, since this is actually the larger steel rod, 3 meters in length, is cut into 8 equal pieces. What is the length in meters of each piece? So if we wanted to actually write this problem out, it would be like this. 8 into, sorry, that's a really crappy 8. 8 into 3. Does that work? Doesn't really, so we have to add a 0. 8 goes into 30. 2 times. 2 times 8 is 16. Actually, sorry. That is incorrect. 8 goes into 33 times. 8 goes into 33 times. 3 times 8 is 24. And then we take 30 away from 24, it equals 6, okay? Does 8 go into 6? It does not, so put another 0 there. So now we can bring down the 0. 8 goes into 60. How many times? Okay, it goes in there 7 times. And the number that you have, so 8 goes into 67 times. 7 times 8 is 56. So then 60 minus 56 is 4. I'm skipping out the little carrying and stuff because this should be easy to do in your head, guys. Otherwise, you go 6, borrow from the 6, make it a 5, make this a 10. 10 minus 6 is 4. 5 minus 5 is 0, so we don't put anything there. But either way, you get the same result. So 4 goes into, does 8 go into 40? Sorry. No, it doesn't. So you add a 0, bring down the 0. Now, does 8 go into 40? Yes, it does. 8 goes into 40 5 times. 5 times 8 is 40. So, there we go. The problem is resolved. So we take the decimal, we put it right up here. So we know our answer is C, 0.375. Okay. And that sums it up for this lesson. Thanks for watching, guys. If you did appreciate that, did help you, hit a like, give me a like and a subscribe as well. Thank you very much. Share it with a friend that may be going through GED as well. And you have a good one.